This is a real Unreal Engine 5.5 C++ line trace test. The first ray is deliberately offset, misses the target, and reports no actor. The second ray travels directly forward, hits the target on the visibility channel, stops at the impact point, and triggers a visible hit response. In this lesson, we will calculate start and end positions, configure collision query parameters, call LineTraceSingleByChannel, inspect FHitResult, ignore the shooter, separate miss and hit branches, and verify both outcomes with real frames, logs, and automation. A line trace is a start point and an end point in world space. The direct ray starts at the shooter, uses getActor forward vector, and extends 1,000 centimeters. The miss test adds a 250 centimeter lateral offset using getActor right vector. Keeping endpoint construction in a pure function makes the geometry auditable. The automation test proves the direct endpoint, the offset endpoint, and that a negative distance clamps to 0 instead of reversing the ray. The target mesh uses query-only collision. Every channel response starts as ignore, then visibility changes to block. The trace calls LineTraceSingleByChannel with ECC visibility, so only components that block that relationship can produce a hit. The query parameters also ignore the shooter actor. Without that exclusion, the ray could intersect the object that emitted it. Collision channels describe intent. This ray asks what visible target exists along this segment, not what should physically block movement. GetWorld LineTraceSingleByChannel receives the output hit result, start, requested end, channel, and query parameters. Its Boolean return value is the first branch. True means a blocking hit was found. False means the full segment completed without one. The code does not read impact data until that Boolean is true. For a miss, the visible beam reaches the requested end. For a hit, it stops at hit impact point. This prevents stale or invalid hit result fields from driving gameplay. FHitResult can identify the actor and component, the impact location, surface normal, distance, trace start, trace end, and additional physical material data when requested. In this test, getActor returns trace target actor 0 and impact point lands at y-62.5, the near face of the cube. The gameplay branch casts the hit actor to the target class and sends the impact point. The target then turns red, tilts, and displays hit confirmed. The first trace uses the same start, distance, channel, and query parameters as the second. Only the lateral offset changes. That controlled difference produces hit false and actor none. 1 second later, the offset becomes 0, producing hit true and the real target actor. This makes the lesson diagnosable. If both traces hit, the miss offset is too small or the collision volume is too large. If both miss, the direction, channel, or target response is wrong. These are 3 real frames from the saved line trace map. The ready state shows the shooter and untouched cyan target. The miss state shows an amber ray passing beside the target while the status reports no actor. The hit state shows a cyan ray ending on the cube, the target turning red and tilting, and both labels confirming the actual actor hit. The camera and geometry remain fixed, so the only meaningful difference is the trace endpoint and resulting collision query. The runtime log records the miss as hit false with actor none. It then records hit true with trace target actor 0 and the exact impact point. Final hit is true and the process exits cleanly. Unreal Automation separately protects the 1,000 centimeter distance, 250 centimeter offset, no tick policy, direct endpoint, miss endpoint, and negative distance clamp. The test passed with 1 success and 0 failures. Visual rays, FHitResult logs, and pure geometry tests all agree. The reusable pattern is 4 steps. Build a world space segment. Query 1 intentional collision channel while ignoring the source. Branch on the Boolean hit result. Inspect only the fields needed by the gameplay response. Keep endpoint math testable and verify both hit and miss cases in a real level. This structure scales to interaction prompts, weapons, object selection, camera obstruction, foot placement, AI site checks, and many other spatial systems.